Good morning. Suppose we have a circuit like this and we are asked to calculate the current flowing here. Because we don't have any series circuit or parallel circuits to calculate the equivalent resistance, we have to do a delta star transformation because we have two delta here, or a star delta transformation because we have two stars here. So let's do this star, this delta, let's transform it into a star. So if we do a transformation, it means that we will have the following circuit. This is the star equivalent of this delta, and let's call this one R3 prime, this one R1 prime, and this one R5 prime. So from delta star transformation, we can say that R1 prime, R3 prime, and R5 prime is equal, R1 prime is equal to R5 times R3 over the sum of the three, R1 plus R3 plus R5. R3 prime is R1 times R5 over the sum of the three. And here R5 prime is equal to R1 R3 over the sum of the three. So this one R3 times R5, this is 80 over the sum of the three, which is 20. So it means we have 4 ohms here. Here we have 20, and the denominator R1 times R5, this is 20, this is 1 ohm, and R1 times R3 is R1 times R3, R1 times R3, it's 80, R3 times R5 is 16, R3 times R5 is 16, this is 0.8 ohms, and R1 times R3, it's 80, and it's 4 ohms. So let's write R1 prime is equal to 0.8 ohms, R1 prime, R3 times R5, R3 prime is equal to 1 ohm, and R5 prime is equal to 4 ohms. So let's draw the equivalent circuit now of this circuit. So we have R5 prime, R3 prime, R2, and here we have R1 prime, R4, and we return to our source and the internal resistance, which is RW. This is 0.5 ohms, and this is 3.9 volts. From here we can calculate the main current I, and we can calculate, let's call this one I3, this one I1. These are needed to calculate this current. Remember the Kirchhoff's voltage law here, phi R5, which is this voltage plus this voltage, this drop plus this drop is equal to this drop. So VR5 plus VR3 prime is equal to VR1 prime. From here we can calculate VR5, it's VR1 prime minus VR3 prime. VR1 R1 prime is equal to R1 prime times I1 minus R3 primes times I3. Let's calculate now the main current I, and later we can calculate this. The equivalent resistance of this circuit is R5 prime plus we have R3 prime plus R2, which are in parallel with R1 prime plus R4. So it means these four resistances are in series with R5 prime and RW, which so it means that the equivalent resistance is 0.5 plus 4 ohms plus this and this R3 prime. R3 prime is 1 ohm, R2 is 5, this is 6 ohms in parallel with R1 prime, 0.8 plus R4, which is 2.2, this is 3 ohms, 6 in parallel with 3 ohms gives 2 ohms, so it means the equivalent resistance is 6.5 ohms. From here we can calculate main current. Main current is V over the equivalent resistance, 3.9 volts over 6.5, and this current is 3.9 divided by 6.5 is equal to 0.6 amps. From here we can calculate I3 using the current divider and I1 in function of the main current, which is equal to I. I3 is equal to R1 prime plus R4 over the sum of these four. It means R1 prime plus R4 plus R3 prime plus R2 times I. Here it's I1 is R3 prime plus R2 over R1 prime plus R4 plus I3 prime plus R2 times I. So it means R1 prime 0.8 plus R4, it means 3 over R1 prime 0.8 plus R4 2.2 plus R3 prime, which is 4, which is 1, and R2 is 5. So it means you have 6, 9 times 0.6. I3 is equal to 0.6 divided by 3. It's equal to 0.2 amps, and here it's 0.4 amps. Knowing I1 and I3, we can calculate the voltage drop in this resistance. This is R1 prime 0.8 times I1 0.4 minus I3 prime 1 times 0.2, so it means 3.2. Let's calculate 0.8 times 0.4, 0.32 minus 0.2, it's 0.12 volts, and from here we can calculate I5 is equal to 5 VR5 over R5 is 0.12 divided by R5, which is equal to 2, so it means that the current is 0.2 0.06 amps. So E5 is 0.06 amps. Of course, we can calculate the I1 here, I3, I4 and the I2 using the same method. And that's it. And thank you very much.